So we're going to talk about two-way tables today, guys. We're starting our newest unit, our bivariate data unit. It's involving scatter plots, lines of best fit, Elijah turnaround, and then two-way tables. I wanted to start with two-way tables because I feel like two-way tables is a little bit easier for understanding than the scatter plots. Not that scatter plots are difficult. I mean, the picture of scatter plots, the understanding of correlations, that stuff is pretty easy. What can get a little tricky is the line of best fit. So I kind of wanted to save that for last. By the two-way tables, this is a segment that you're either going to really get or you're really not. So I'm just going to throw that out there for you. You're going to either really get it or you're just really not. There's not a whole lot of in-between of, oh, I kind of get it. It's yes or no. So you need to make sure that you're paying very close attention to it. So the first thing that I want to do is start off by giving you a two-way table, and I'm just going to focus on explaining what the two-way table represents first, and then I'm going to ask you some questions, and you're just going to answer them for me based off of a, yes, that statement is true, or that statement is false, okay? So what a two-way table is it's taking two sets of data and putting them in a table to compare them with totals. So let's say that we've got bilingual students. So we're talking about some students who are bilingual, and we've got students that can speak Spanish versus students that can not speak Spanish. And then we get the total. And then we're going to make the comparison to students that can speak English, not English, and then of course a total. Okay, so the number of students who will speak Spanish and they'll speak English, we'll say there's 30 of them. Number of students who speak Spanish but do not speak English, we'll have 20, which means we're going to have a total of 50 for the Spanish speaking. Then we've got not Spanish but they speak English, we'll say is 65. Not Spanish and not English, so they speak some other language, is 5. That's going to give us a total of 70. Now if we focus on the totals for English, our English total here is going to be 95. Our non-English total is going to be 25. And then right here where we have that connection, this represents the total number of students in all. The total number of students in all. Which means when I calculate 50 plus the 70, it should equal the exact same value as 95 plus the 25, which is going to be what? 120. So how a two-way table works is it's making a comparison of two different situations, and you either are that situation or you're not that situation. Or you're a combination of the two situations, a combination of one and not another, or a non-combination of both. So here, this means, hey, we've got out of 120 students that were surveyed total, we have 30 students who speak both Spanish and English. If I were to go to this number right here represents that there are a total of 70 students who do not speak Spanish at all. That's what they represent. They don't speak any Spanish. But if I focus on each of the individual numbers here, there are 65 people who don't speak Spanish, but they at least speak English. 5 students who don't speak Spanish, and they don't speak English. So there's just a different way. You've got this table set up, and then when we ask you questions based off of it, you're just going to have to go through and look and see, okay, well, is this a true statement or not? So my question to you for number 1. The majority of students don't speak Spanish. I want you to indicate to me, is that true or not true? Is it true or false? So what you're going to do when we're talking about majority of students, in this case when they're saying students, they're not putting a limitation on it. So that means that we're focusing on what value for our total? 120, right? And you have to understand when I'm saying what total are we focusing on, we've got a lot of different totals, don't we? What does this total represent, this 95? The people who speak English. This total represents what? The people who speak Spanish. This total represents, and this total is, and so that means this total represents all the students, right? All the students that we're talking about. So we have 120 students. Now they're saying that the majority of that total don't speak Spanish. So now what number are we going to focus on? 70. So 70 compared to 120, is that the majority? Yes. So is this statement true or false? True. Use a green. So we'd say true, and then of course we want to give a statement as to why that statement is true. It's true because of the 120 students, 70 do not speak Spanish. Yeah. Well, no, two-way means that it's comparing two different types of data. So we have data talking about Spanish speakers and data talking about English speakers and where they overlap. It's kind of like almost like a Venn diagram would be. Okay, you've got people who are just Spanish, people who are just English, and then where do they overlap? Okay? All right. There are more Spanish speakers than English speakers. You're going to indicate whether that is true or false. What do you think, Jordan?
Oh, false.
Why?
Because it says there are more Spanish speakers than English speakers, and on the total for non-English speakers, there's 25, and for English, there's 95.
Wrong numbers to focus on. Kendall?
On the Spanish one, the total is 50, and on the English, the total is 95 and 95.
There you go. So the numbers that we're going to focus on is how many total Spanish are there compared to how many total English there are. So you've got 95 people who are focusing on being able to speak English and 50 people who are able to speak Spanish. So English is the more common spoken language amongst this group. So this would be a false statement. So we have false because there are 95 English and only 50 Spanish. And then, of course, 95 is greater than 50. So you guys get the basic idea of how to look at the table and read it? That part's simple. What can get more tricky and that's the part where you either get it or you don't. It's constructing the table when given only a couple pieces of information. So that's what we're going to focus on doing right now, is constructing. So, let's say over 3. There's 150 kids at camp. 71 signed up for swim. There are a total of 62 kids signed up for canoe, and 28 of them are also swim. So what we're going to do first is we're going to construct a table. Okay, so what are my 2 categories? Canoe and swim. So you are either going to canoe or not canoe. And then of course you've got a total. You are either going to swim or not swim. And then of course you've got a total. So now what we have to do first is we've got to figure out where we're going to place the information that they gave us, and then we're going to have to fill in the rest on our own. So let's start with there are 150 kids at the camp. That value, where is that going to go? Raise your hand and tell me under what box is it going to go? Heaven. So, under in here, where at? The very bottom? Yeah, so what you would say is it's going to go under the total, right? Total. Here you would say, oh, hey, this is going to be canoe, swim, or it's going to be canoe, total, and that's how you would read it. Okay, so this is going to go under the total, because it's 150 kids at the camp. All right, 71 signed up for swim. Who can raise your hand and tell me where am I going to put that number? Grant.
You're going to put it under, to the right of swim.
Right here?
Yes.
Now, it just says that they're talking about swim only, right? They didn't talk about canoeing for that. It says 71 signed up for swim, so it's swims total. There you go. It's swims total, so that's the 71. All right. There are a total of 62 kids signed up for canoe. Nathan. The canoe total. $28 of them are also swim. Ian. Canoe swim. Very good, because we're talking about 28 of them. The them that we're focusing on is of those people who canoe, there's also 28 of those people who swim at the same time. So we've got 28 for our canoe swim. Now, that's the only information that they've given to us. The rest of it's kind of like a puzzle where you've got to figure out what value is going to be pieced into what. So easy things are things like right here, the swim but not canoe. How do we figure out swim but not canoe's value? Lena? Very good. So we're going to take that 71 for the total, and we're going to subtract 28, and that's going to give us what? 43. So we have a value of 43 here. So I'm just going to write down what we did in the little corner, but I know that this value is 43. Okay, figure out some of the other ones. Who can tell me what another one's going to be? Colin? The not canoe and not swim is 45. How did you figure out this one based off of what I've got here right now?
I did the two total 62 minus swim, which gave me 34.
So you had to find this one out first, right?
Yeah.
So let's go in order of what we had to find out first. So you did 62 minus 28 to get what? 34. So he found the canoe not swim by subtracting 62 and 28 and get 34. Okay. What else do we kind of have to do? What's the next one that we have to do in order, Arham? Okay. Very good. So you could either go here or here, doesn't matter. You could do 150 minus the 62. Okay, Elijah. That's going to give us 88. Shh. Remember, we're recording. Okay, or we could do the 150 minus the 71, and that's going to give us 79. Okay, and now once we've gotten that stuff filled out, there's two different things we could do to figure out this one. We could have done 88 minus 43, or we could do 79 minus 34. Either way, we're going to get 45 here. But like I said before, they only give you like 3 or 4 pieces of information, and then you have to use that information to figure out the rest. Okay? And then from there, then you can answer questions about it. So, for example, I could say, well, hey, what's the frequency, what's the relative frequency of, you know, swim to canoe? So the relative frequency of swimmers to canoers. That means I'm going to have to look at how many swimmers there are, which is 71, compared to how many canoers there are, which is 62, and set that up as a fraction, 71 over 62. Always leave it in improper form or decimal form. Okay? I could say questions like, what's the frequency of swimmers to all? So then I would say, okay, well, there's 71 out of 150. Why are you sharpening a color pencil right now? Okay, I haven't used orange. You better not be coloring. Okay. All right, let's go on to another one. Shh. Oh, I'm so sorry. right, there's 195 males and 126 females in Northbrook Middle School 7th grade. Survey showed that 110 of those males and 84 of the females ride the bus. So I want you to construct a two-way table. You guys go ahead and construct it. Go ahead and answer those two questions too after you're done constructing it. So the majority of people who, males that do not ride the bus. So males that do not ride the bus. So it would be this with this. All right, let's go ahead and fill it in. Who can tell me where am I going to put the 195 males? Mateo. For the total of males. Very good. So this is where 195 is going to go. Stop it, boys. I'm not calling on either of you.
No, that's wrong.
Oh, oops, sorry. I put it in the wrong spot. My bad. I put it in the wrong spot. He said it right, and I wrote it wrong. Thank you. So let me cross that off. Where am I going to put the 126 females? Where is that going to go? Lena? Female total. What about the 110 males for the bus? Chelsea. The bus male. And then the 84 females for the bus. Lena. Female bus. Okay? All right, so now let's go ahead and fill in the rest of the information. So for here, how much is the bus total going to be? Heaven? 194. How much is the total going to be? What's the total? Jordan?
321.
Okay, what is the amount of males that do not ride the bus going to be? How much was males who do not ride the bus? Hillary? 85. How much was the total for females that do not ride the bus? How much was that, Kendall? 42. And then Morgan, how much was the total that do not ride the bus at all? 120. 127. All right, so now that we've got all this written in, let's talk about the relative frequencies. What is the relative frequency of males that do not ride the bus? Males that do not ride the bus. So what two values are we comparing here, Elijah?
The total over the males who don't ride the bus.
It's going to actually be males who do not ride the bus over the total. And which total? Because there's a lot of totals. Are we talking about totals of males, totals of females, totals of bus, totals of no bus, totals of totals? Totals of?
Males.
See, that's the thing. It doesn't indicate that it wants to do it out of just males. So if it doesn't indicate that it wants to do it just out of males or out of people who ride the bus in total, then you focus on the total. You focus on the total. So the males who do not ride the bus is 85 out of the total, which is 321. So we're going to set it up as 85 over 321. Can that be simplified?
I don't know.
No. Shh. There's 85 who are male that don't ride the bus out of all the total students.
Oh, okay.
Okay? Here, what is the relative frequencies of females that do not ride the bus to males that do ride the bus? Kendall?
21 over 55.
Okay, because you simplified it, right? So females that do not ride the bus, which was 42, out of the males that do ride the bus, which was 110, 110, and then of course you have to simplify it, 21 over 55. Okay? Are there any questions? Okay, so you're going to have a worksheet that you're going to have to do tonight.